Hi guys, welcome to lesson 1. Technically the last lesson was just kind of a review. So this is our first real lesson looking at reciprocal trig ratios. But before we do that, let's do a little warm up. You can try this by yourself if you want. Press pause and give it a shot. Otherwise you can watch me go through this. So the first one, it says solve tan theta equals 0 from 0 to 360. So this is one of those special cases because it's at 0. It's not part of those two special triangles, the 45, 45, 90 or 30, 60, 90. So we have to think of tan of any angle as being y over x. So when you think of that, in order to equal 0, this has to be 0 on top. So I'm just going to write that down. So in order for the ratio to be 0, it means y must equal 0. So I would ask you, why could it not be x? Why can x not be 0? Well, if it was, then you would have something divided by 0, which would give you an undefined value, and that doesn't make any sense. So it has to be the numerator that's 0. So when you think about this, I think it's easiest to think about the unit circle and imagine when in the circle, and I can't really draw a circle, but imagine this thing here. When in the circle is y equal to 0. So the only time y is equal to 0 when drawn in standard position is when you're right here or you're right here. So any other time, y is going to be something that is going to be greater or less than 0. So what we need to do is think about, okay, this is when y equals 0. So what is the angle that creates that case? Well, that's easy. That's just 0 degrees. Or technically, you could wrap the whole way around and it would also be 360 degrees. So that's the one situation, or two situations. And then the other one is when it's over here and y is 0. And that's when my angle is 180 degrees. So in this case, and you can always test this, if you typed in tan of 0 degrees, that's 0. And you did the same with tan of 180, you would get 0, and tan of 360. Therefore, our answers are possibly 0 degrees, 180, and 360. And it's one of the only times you get 3 answers in these questions because we're having a value that started, one of our answers was 0, so it also could be 360. So that's one of those special cases. You look for that whenever it's not a special triangle value. So the next one says determine the exact value this time of 240. So let's just sketch this. So I can do 240, that's somewhere here. Something like that. 240. Always what we need to try to use in this case is try to find what alpha is. So if you think of this one as being 240 minus 180, that gives us an alpha or related acute angle of 60. So in the special triangle, that means it's probably easiest just to draw it in the sketch here. Opposite 60 is the value root 3. And then my hypotenuse gets the 2, and opposite the 30 degrees, so this would be 30, I get a value of 1. So this one's not too hard. The sine of 240 is equal to the opposite over the hypotenuse, which is root 3 over 2. And then the only other thing we need to think about is that is sine positive or negative in this quadrant? And so because we're in the t quadrant, it means sine is negative, so I put a negative there. So that's it. So if you have any questions about that, let me know. So just to reiterate, you really need to know these special triangles, and some people memorize the table, and that's totally fine. Other people will just memorize these two triangles, and that's great. So remember 45, 45, 90, we have the opposite sides to the 45s of 1, and then my hypotenuse is root 2. And then this guy, which is the 30, 60, 90, gets values of 1 like we did just above, root 3 and 2. Okay, we're going to use that stuff a lot today. So, you know how we've had questions that have said, oh, find the 3 primary trig ratios. And it's like, well, why are they calling them the primary trig ratios? The fact is there are other trig ratios, and these 3 other trig ratios are what are called the reciprocal trig ratios. And that's what we're going to look at today. So what the heck is a reciprocal? Well, we've dealt with this before in math, but it's really just something where you flip it over. So reciprocal function is the function flipped over. So let's say you had a fraction of 3 over 2. Then the reciprocal of that would just be 2 over 3. So each sine, cos, and tan has the reciprocal version of itself. Probably the hardest part of this is just remembering which ratio matches up with which sine, cos, or tan. And so if we look here, I'm just going to highlight while I'm talking. So we've got sine, obviously, is just opposite over hypotenuse. Its reciprocal trig function is what's called cosecant, which gets short formed into CSC. And because sine is opposite over hypotenuse, cosecant just flips that and makes it hypotenuse over the opposite, which is just the reciprocal, just like we did here with 3 over 2 equals 2 over 3. And so, again, probably the hardest part is just remembering cosecant goes with sine. There's a couple ways to try to remember that. The sine, which starts with an S, goes with the C cosecant. Whereas the cosine, which is the one below, goes with the secant, which is an S. That's one way to think of it. And so secant is, again, reciprocal, so we take hypotenuse over the adjacent versus the adjacent over hypotenuse. And people will ask, why the heck do we need this stuff? Well, part of it we're going to see later is that you use this when you're doing a lot of proofs in trigonometry. And so it will make more sense later on, but not necessarily in this lesson. But it does add a level of complexity that makes things a bit trickier. And then the last one here, tangent, has its reciprocal, which is called cotangent. And cotangent, just instead of opposite over adjacent, it's adjacent over opposite. Another way to think of these things is that you have 1 over the function. And so cosecant is really just 1 divided by sine, secant is 1 over cos, and tan is 1 over, or cotangent rather. So another way to think of how to remember this is that you can try to match up who matches with who to remember that a so like cosecant, matches with something that doesn't have a non-co. So cosecant matches with sine, cosine matches with secant, which is the only one for the reciprocals that doesn't have a and then tangent, which I think is the easiest one to remember, goes with cotangent or cot. So the short forms of these are CSC, sec, and cot. Very peculiar sounding things. So just to reiterate this stuff, if we looked at our primary trig ratios for sine, cos, and tan for our exact value stuff from our special triangles, I'm going to put these in. So you can try to fill this in for practice if you want and pause the video. But we end up with all of these. I'm going to write the versions that are not rationalized in the denominator for now. But if you want to rationalize them, you can. Eventually we will, but I think for the moment it's easiest to not do that. So there are the things we've seen many, many times. So the reciprocal trig values for cosecant, secant, and cotangent, and I've matched them up so sine is matched with cosecant. So I just simply take 1 over 2 and I flip it so it becomes 2 over 1. So that's matching this guy with this guy. And so really that's the same as 2. And then if I do the same, if I go down, let's say, then this becomes secant, which is matched to cosecant for 30, is just 2 over root 3. And so this guy, if I choose a different color, matches with this guy. And then the last one, tangent and cotangent, instead of 1 over root 3, I get root 3 over 1 or just root 3. And so this is the last one I'll highlight, but you get the idea hopefully. And so if I take sine and then do the 1 over or reciprocal for cosecant, it just becomes root 2 or root 2 over 1. And this similar root 2 here. The reciprocal of 1 is just 1. And if I keep going for the other ones, I just keep flipping everything. And this becomes 1 over root 3. Great. So we're going to use that stuff, but there's a lot of stuff, and this is a good review from last unit because we're going to really try every kind of question that we did last unit. Only now we're going to incorporate this idea of the reciprocal. So an example we would have had last unit is this question where it says give the primary trig ratios for a terminal arm that passes through a point. And so now you'll notice it says all 6 trig ratios. So that means sine, cos, tan, cosecant, secant, cotangent. So the first thing we need to do is to sketch this. So if I have -1, so let's say this is -1 here, and I'm going 0.3, 1, 2, 3. So I've got something like this. And so my terminal arm drawn from the origin goes through that. And so I can create my quarter of the bow tie, and I've got my 90-degree angle there. What I can do is label the sides. So I'm just going to change colors so that my height here, the y value is 3, the x value is -1, and then I've got, let's call it the radius or r here. R, or the hypotenuse, is just going to be the same. Remember we did this before where I take this, each side, square them, and add them together. So I end up with 10, or r squared equals 10. So my hypotenuse is actually just root 10. So if I could, I would reduce that, but I don't think there's a perfect square in it, so I'll leave it. So now what I want to do is to write out all of sine, cos, and tan. So let's start with the regular primary trig ratios. So sine, remember theta looks like this, and theta is always related to alpha, which is the related acute angle. So sine of theta is the opposite over the hypotenuse, which is the same as sine of alpha. So I write it in, so opposite in this case is 3, my hypotenuse is root 10. I'm just going to change that so it's got the same trig ratio, or I'm going to rationalize the denominator in this case. So I'm going to multiply the top and bottom by root 10, so I end up with 3 root 10 over 10. So there's that trig ratio. They're not asking us to find theta, so we don't have to take another step. We're just getting the ratios. So the next one, cosine, I've got adjacent over hypotenuse. In this case, adjacent is -1. Hypotenuse root 10. I rationalize the denominator, so I end up with negative root 10 over 10. And then tan, opposite over adjacent, so I end up with 3 over -1, which is the same as just -3. Great, so there's my 3 primary trig ratios. What I want to do now is get my reciprocals. So the reciprocal for sine is cosecant. So all I do is I flip the fraction. But I'm going to choose to flip this version, otherwise I'm going to end up with something that has a radical in the denominator. So this one, if I flip it, I just end up with root 10 over 3. So that just makes it a bit easier. So I do the same thing here, or similar with cosine. So that's secant. I'm going to choose this one again. So I've got negative root 10 over 1, or just negative root 10. And then the last one, cotangent, becomes, instead of -3 over 1, I've got -1 over 3. And there's my 6 primary trig ratios, or 6 trig ratios that we're going to use. So again, nothing really new other than adding this last step of putting these 3 reciprocals in. Okay, so this one we're going to use our calculator. So it says using your calculator, calculate each ratio to the nearest hundredth. So secant, and there are some calculators which will have these reciprocal buttons on them. If yours doesn't, what you need to do is just simply think of it as the flipped. So it becomes 1 over And secant matches up with cosine, so it becomes 1 over cosine of 20. And so if you punch that in and just put this all in brackets on your calculator, you should get 1.06. Make sure you're in degrees, of course. So similarly here, I've got cosecant. So instead, on my calculator, I type 1 over sine of 220 because sine matches up with cosecant. And so you end up with approximately a negative 1.56. So that's dealing with the calculator. Next one here, it says calculate the exact trig ratio using the special triangles. So they've kind of told us what to do here with the exact value in special triangles. So cotangent, you could go back up to the table we did, but I'm going to do this in a kind of methodical way. Cotangent is really going to be the same, only flipped version of tan. So if I think of tan of 30, that might be a bit easier. So remember this triangle, and I'll just redraw it. There's 30, opposite 30 is 1, there's 60, opposite 60 is root 3, and then the hypotenuse is 2. So tan of 30 would be opposite, which is 1, over adjacent, which is root 3. So therefore, cotangent of 30 is just the flipped version of that, which just becomes root 3 over 1. So cotangent 30 is root 3. This one, again, we're going to do something similar, only they're multiplying the two together. So I'm going to think of this one first. So secant matches up with, and you can try to figure this out on your own. So that's cosine. Cosine of 45 is 1 over root 2. So therefore, secant of 45 equals root 2. Next one's a bit more complex. So I'm going to do it to the side. So cosecant matches up with sine. So now we've got something that's greater than a 90 degrees. So if I do that, what I want to do is, if you need to, draw this out. So I'm going to draw this out down here. So 240 is somewhere here. So I think of it just like I normally would. So that's 240. My related acute angle is what's important. So alpha in this case would be 240. I subtract 180 and I get 60 degrees. So if that's 60, and then I use the special triangle over here, opposite 60 is root 3, opposite the 30 is 1, and the hypotenuse is 2. So therefore, if I try to figure out sine of 60, which is the same as sine of 240, it's going to be opposite over hypotenuse, so that's root 3 over 2. The only thing I have to consider is that in that quadrant, is sine positive or negative? So in this case, we're going to have a negative value. So if that's the sine, now I got to go back and say, okay, well, I'm actually getting cosecant. So cosecant of 240 is going to be the flipped version, or the reciprocal. So I get negative 2 over root 3. And I'm going to leave them not rationalized at the moment, but you can definitely rationalize it. So if I now go back to the question, so we're going to actually answer the question, hopefully. So secant 45 times cosecant 240 equals root 2 times negative 2 over root 3. So I've got root 2 times the negative 2, so the numerator becomes negative 2 root 2, and the denominator is root 3. The only thing we have to do now is to rationalize the denominator. So I'm just going to multiply both the top and bottom by root 3. So I end up with, I can multiply my roots together, so I've got negative 2 root 6 over 3, and that's my answer. So that's the simplified version of that above. Okay, so it gets a bit tricky as we go through. Next one's definitely tricky as well, but let's try to approach it just like normal. So cosecant, first thing I want to do in almost all these questions is think, what is the actual primary trig ratio that matches with this? So that means this is the sine. So cosecant matches with sine, and it's the reciprocal of that value. So this is like having 2.9 over 1, so this becomes 1 over 2.9. So that gives me something to start with. And so if it's a positive value, which it is, this is positive, that means sine is positive in which two quadrants? So CAST. So that gives me quadrant 1 and quadrant 2. So I know automatically I'm going to have two angles. One is here and the other one's here. What we need to find first, though, is alpha. So alpha is going to be just the inverse sine of this. So if I do that, alpha in my calculator will tell me 20.2 degrees. So that's actually our one answer. Theta 1, which is here, so theta 1 is just 20.2, or approximately 20.2. The second answer is going to be this one, which is theta 2. So to calculate that one, remember we take 180 minus 20.2. So we end up with 159.8 degrees. So almost always as a first step in these questions, you have to go and think, okay, what's the actual primary trig ratio, and then work with that one. So you can actually try this one if you want yourself. This one, we've got secant. So first thing I'm going to do is I'm going to change it into its primary trig ratio, the reciprocal one. So secant matches with cosine. So if I do that, cosine would be the reciprocal of this, so it becomes negative 5 over 7. So a couple options here. One, if this is negative and it's cosine, tell me where it's going to be located in the quadrant system. So that means it's going to be in quadrant 2 and quadrant 3. So that means I know I'm going to have something here and something here. So in order to figure that out, let's find alpha. So alpha will be the inverse cos of these. So if you punch that in your calculator, you get roughly 44.4 degrees. So that means if I want to find theta 1 is going to be 180 minus that. So that becomes 135.6. And then the second one, you can try this yourself, theta 2 equals 180 plus that primary or related acute angle. So I end up with 224.4. And there's my two answers. Okay, so that's the sum of it. What's hard about this is that you're really dealing with a whole bunch of different types of questions, and you need to be able to try to figure out what to do with each type of question. So I've posted the solutions to the you try part. So if you want to, you can stop the video here and try this. Otherwise, I'll talk my way through this stuff. So again, pause it, try these out. So the first one, we're trying to draw this one. So again, I draw this point 4, and I'll just highlight as I go through. So I got 4, negative 6. So when I do this, I need the hypotenuse. I do the hypotenuse, I get 2 root 13. And that allows me to find all of the trig ratios, so sine, cos, and tan. And then I need to take the reciprocal of those. Notice I chose this version in order to take the reciprocal, just so I didn't have to rationalize the denominator again. So that one's not too bad. Next one again is like the second one we did, which is using your calculator, calculate each ratio to the nearest tenth. So in this one, cotangent matches up with tangent, so I just flip it so it becomes 1 over that, and I punch that into the calculator. Same with this one, 1 over sine of negative 50, and it gives me the answer. I think the next two are where it gets a bit trickier. So number 3, it says the cotangent of 330. So what I should do is just start, okay, well, if I can find the tangent of 330 degrees, then I can figure this out. So here I drew it. So tan of 330 gives me this situation where alpha is 30, my related acute angle. Opposite of alpha, 30 degrees, is 1. Adjacent is root 3. So I end up with tan of 330 is 1 over root 3. The only thing I have to add in here is that because I'm in this quadrant, tan is negative in that quadrant. So I end up with a negative 1 over root 3. So cotangent of 330 is just the reciprocal, so that becomes negative root 3. So which is really just one extra step from what we're used to. Next one says cosecant 270 is really the same as sine of 270. Sine of 270 is a bit tricky. You can just punch that into your calculator. But this is one of those special cases where you rate on the y-axis. Because you rate on the y-axis, you end up with this situation where, if I just sketch it, you're really here. So this is 270. And sine is the same as y. Here, y equals negative 1. And so you end up with this value of negative 1. And then, so therefore, the cosecant of 270 is the reciprocal of that. Well, the reciprocal of 1 is just 1, or negative 1 becomes negative 1. Next one is secant of 300. So again, change to cosine. Cosine of 300, you can draw this if you need to. Figure it out. Related acute angle 60, so that makes this 1/2. Therefore, secant of 300 is the reciprocal of 1/2, which is 2 over 1. So now we've got all of these values, we can plug them in. So you end up with just negative 1 over 2. Not too bad. Next one, again, a bit trickier. So this one says solve for all unknown angles to the nearest tenth between 0 and 360. So these ones are probably the hardest ones. In this one, we've got cotangent is this. That means first thing to do is to switch it back to tan. So I got tan is this. So tan is the reciprocal of that. So if I think of that, tangent being negative means it's in these two quadrants. So I draw that. I can figure out the related acute angle. You can use your calculator to do that if you want by taking the inverse tan. Or you can use your special triangles. So I end up with 30. So if it's drawn in those two quadrants, then I've got theta 1 here calculated and theta 2 based on those two quadrants. Again, I'm going pretty fast, but hopefully most of this should be a review. But if you have any questions or you want me to talk you through it, I definitely can chat with you online. Next one is cosecant y, which is same as sine. So I flip that, I flip my base, and because it's negative, I'm in these two quadrants for sine. So again, use your calculator, find alpha, you get the related acute angle, and then you can solve based on that. Okay, I will post these pages, I think it's a couple pages in the textbook, and I would ask that you post your solutions when you're done onto Edsby. Please don't hesitate to call me, visual or audio, doesn't matter, and we can go through anything if you have